All right, so we're going to move on in factoring today, and we're going to go over factoring. This is more typical of what we consider factoring by undoing double distribution. So thinking about two binomials, x plus a times x plus b. So let's just go through and look at what happens when we distribute these out. So remember, if you have two quantities multiplied together that both have two terms within them, you need to distribute both terms in the first quantity to both terms in the second quantity. So in this example, if we have x plus a number times x plus a number, x times x is x squared, x times b is bx, a times x is ax, and a times b is ab. Then we would combine like terms. We only have one quadratic term. It would remain as x squared. We only have one constant term. It would remain as a times b. But we do have two linear terms, two x terms, and we combine those by adding, so that would be the quantity a plus b times x. That might be a little bit confusing for some of you, so let's go in and look at an example using actual numbers. So let's say, excuse me, we have the quantity x plus 3 multiplied by the quantity x plus 4. We double distribute. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 3 times 4. So then x squared remains just x squared. We can combine 4x and 3x to make 7x. And 3 times 4 gives us our constant of 12. So we know that these two things here are equivalent, and this also means that x squared plus 7x plus 12 factors down to x plus 3 times x plus 4. Another good thing to remember is that the order of this multiplication does not matter. Just as 3 times 4 is the same thing as 4 times 3, this x plus 3 times x plus 4 is the same if the quantities are in reverse order. You could write x plus 4 first, multiplied by x plus 3. That would still be the same thing. So if you notice, in our two numbers, our constant term is the product of the two numbers within the binomial factors. Our linear term has a coefficient that is the sum of those two numbers. So whatever those two numbers are, you multiply them together to get the outside constant, and you add them together to get the middle linear term. So here, 3 times 4 gets us the 12 out here, and 3 plus 4 is where we get the 7x. So that's the idea that we're going to use in factoring, and I'm going to just do one more example of this, and I'll show out some work. So we're going to try to factor x squared plus 9x plus 20. So remember, if we're factoring it this way, where we have two numbers a and b, those numbers will multiply together to give me 20, and will add together to give me 9. So we want to look at types of numbers, pairs of numbers that multiply together to get us 20. So I'm going to go ahead and write all of them out. If you recognize the correct pair, you can just go ahead and complete the problem. But the different ways that we can multiply whole numbers to get 20, we can do 1 and 20. We could do 2 and 10. 3 does not go into 20, so we can't use 3. The last pair we can use is 4 and 5. So these are the possible numbers right now that could go in for a and b that would give us a constant term out here of 20. 1 times 20, 2 times 10, 4 times 5. We want these numbers to have a sum of 9. So when we add these numbers together, if the numbers were 1 and 20, the sum would be 21, and we would have a 21x in the middle. If the numbers were 2 and 10, the sum would be 12, and we would have a 12x in the middle. If the numbers were 4 and 5, the sum of those are 9, and we would have a 9x in the middle, and that is the case here. So that tells me that the two numbers in the factors are 4 and 5. So our answer is the quantity x plus 4 multiplied by the quantity x plus 5. And again, that is the same thing as if we switch the order. the quantity x plus 5 times the quantity x plus 4. Those are both correct answers. You don't have to give both. Either one would be fine. You would just select one of these two answers, both being correct.